Hi, Year 11s. Today what we're doing is we're going through another revision material lesson. It's all on 8.4, identification of ions and gases. Now, I know that a lot of you have got incredible amounts of work to do, so really, I mean, like, your priority is to make sure that your portfolios and files are fully scanned. That's really the most important thing that I'd like you to do. But I do still have to set some work reluctantly, or might I say, because your portfolios are really important. Nevertheless, what I need you to do is I just need you to just show me that you are on top of this information. I've had a look on Seneca and I can see that there is an opportunity for me to give you some interactive work with section 8, which is this section. So let me go through what I'd like you to do in as brief a time as possible. So it's all about identification of ions and gases. There's a lot of this which is really from the core section, which is describing the following tests to identify aqueous cations. And here we have the specification, so you can actually see again, you know, this everything is core stuff, so it's just pretty much recall. It's being able to remember how to test for each one. You got cations, metal cations over here: aluminium, ammonium, calcium, chromium 3, copper 2, iron 3, and zinc. You can use aqueous sodium hydroxide and aqueous ammonia as appropriate. You get some nice precipitates in a couple of these. Formula of complex ions you're not required to use. That's absolutely fine. That's more of an A-level thing. So it's not going to be something that comes up. Cations, using flame tests to identify lithium, sodium, potassium, and copper. But there's so many other flame tests that you could also identify. Things like barium, which is a nice apple green. You've got anions, which is carbonates, so there's a nice easy one for you, which is lime water. Chloride, bromide, and iodide we did early in the year, so that was actually the one that we took outside, and we found that the silver halides discoloured as well, so there's an application of that with photographic plates. Nitrate, by reduction with aluminium, that's an interesting one. You've got sulfur, sulfate, acidic conditions with aqueous barium ions, so the key phrase for that is white precipitate. And also the reason why you add acid is to try and get rid of any carbonates, because some of the barium carbonates can give you a false reading, so just remember to have an acid in there as well. And make sure that the acid is not actually higher sulfuric acid as well. It's a nice little trap that they can lead you. So if you put sulfuric acid as your acid, you've already got sulfate, so you're going to get a false test straight away. And the other one finally is sulfite, by reacting with dilute acids and then aqueous potassium manganate. Okay, so gases that you need to be able to remember as well: ammonia, damp red litmus paper. Works with that one. Carbon dioxide, we're using lime water, chlorine. Damp litmus paper, now it will go red, so blue litmus paper will go red, but then it will bleach as well. So that's the clear difference between, there's a clear difference between the chlorine test and the ammonia test as well. I mean, ammonia will trigger off red going to blue, but chlorine also goes from blue to red, and also gets that bleaching effect as well. Hydrogen, lighted splint, I mean, you know, that's textbook year 8 stuff. That's oxygen, glowing splint, again, sulfur dioxide using aqueous potassium manganate. Although there is another test for sulfur dioxide that I've been teaching in the year 8s. It's acidified potassium dichromate. And the potassium dichromate is orange and it will turn green. So that's quite a nice one as well. I believe that you use sulfuric acid for that to get it acidified. And it's a solution, and then you just generate the source of sulfur dioxide and just bubble it through from one test tube to the other via 2 test tubes and delivery tube. Okay, right, so that takes care of going through like the spec. I'm going to cheat my way through this. This is Save My Exams. And I'm going to just take you through quickly the identification of the aqueous cations. So I'll just take you through this, and then I'm going to set you off with Seneca stuff. So testing for aqueous ions, you can look for the colour of the precipitate they form on addition of sodium hydroxide and ammonia. So if only a small amount of sodium hydroxide is used, then normally the metal hydroxide precipitates. Okay, you get metal hydroxide because you just have such a large chunky set of oppositely charged ions, and they can't break up. The water can't actually dissolve them. And in excess sodium hydroxide, some of the precipitates may dissolve. So you kind of like force the equilibrium to push hydroxides in to bond with the metal ions, and when that happens, then you actually get ionic charged precipitates. The metal cations are then surrounded by several different hydroxide ions. It becomes negatively charged, and when you have negatively charged, it's very easy to dissolve in water. So that's kind of like the science behind that. In excess NaOH, some of the precipitates may dissolve, as I said. A few drops of NaOH added at first. So what you got to do is you got to make sure that there are subtle descriptions in your methods. Add a few drops, observe. Okay, then you add in excess, and then you observe. So a few drops of NaOH. Note any color changes, precipitates form. Then the sodium hydroxide is added in excess. Steps are repeated for the testing using ammonia. Now, ammonia is interesting as well because ammonia is actually a stronger ligand compared to hydroxide as well, so you get some different color ranges with that. So you add the ammonia or add the sodium hydroxide. Don't add them both, okay? It's I know the spec says on addition of sodium hydroxide and ammonia, but one test is with hydroxide, the other test is with ammonia. If you add it too quickly, you're going to miss the formation of the initial precipitates. So it's not a very pleasant list to have to remember. You have to remember all of the different colours. It's not easy to remember. A lot of chemists, in the reality of the situation is a lot of chemists actually look at lists. But the most accomplished chemists amongst you will be able to remember this table that's coming up shortly. There is a little error on Save My Exams. That's why teachers are better. Ca2 plus ions can be distinguished from Zn2 plus and Al3 plus, as Ca should be open bracket OH close bracket 2 calcium hydroxide precipitate does not dissolve in excess sodium hydroxide, but both zinc hydroxide and aluminium hydroxide do. So we're going to look at the table very, very shortly. Okay. If precipitate is formed from either sodium hydroxide or aqueous ammonia, then the hydroxide is insoluble in water. Okay, so you're not going to get a transparent solution. You might, you'll definitely get some like clumpy precipitates. The zinc ions can be distinguished from aluminium ions. Zinc hydroxide, and again here's another error here, Zn open bracket OH close bracket 2, and that's how it should say. That's what it should say. It dissolves in excess aqueous ammonia, but aluminium hydroxide does not. Most transition metals produce hydroxides with distinctive colours. So this lends itself to a little quiz, and what I would have done if we were teaching together is I would have printed this off as a little grid, and then I would have allowed you to cut these rectangles and snip them. What you might wish to do is you might wish to utilize the way in which you've learned how to do this kind of thing. So what I'm going to do is I'm just going to clip it into your slides. So you're going to find this when you go through the video, and I shall leave it to you to turn this into a revision source. So it's quite nice because then what you can do is you can snip the metal cation. You can basically cut along these grids, print this sheet out, cut along the grids, and then just cut along horizontally, vertically, and you've got yourself a set of revision cards, and you can just keep them in a very small envelope or a plastic wallet, label it tests for cations, and it's a nice little jigsaw that you can piece together. That'll be quite useful as well for your journey and transition into A-level as well, especially when you start covering your inorganic section. So, talked about Seneca in a little bit. Colourless is what you see when there is water, okay? Colourless is basically, there's no colour, you can see through it. Okay, clear could have a colour associated with it. So let's see, say for example, you've got the drink Vimto. That's not colourless, but it is clear. Okay, clear, transparent, and it would be purple. Okay. A solution that loses its colours become colourless. Clear solution is one that you can see through, such as water, and solutions can be clear and have colour. Okay, that's the distinction that I've just said. All right, okay, so you got some nice detail here. Just have a look through those. So with aluminium, you get white precipitate, dissolves in excess, NaOH forms a colourless solution. You get a white precipitate, insoluble in excess ammonia. That's the way to distinguish between aluminium and zinc. Okay. So gelatinous just means like a jelly. So just think like a chewed up marshmallow. That's pretty much gelatinous. Okay. Have fun with those. If you print it out on black and white, what you could do is you could colour these in the colours that there are with the precipitates. That would be quite an interesting way to revise. Flame tests, I hope you're very familiar with. Different colour flame tests that you need to know are there. Again, what you can do is you can get this chart, and I'll put it in the slides again. So again, if you really are forgetful with your flame tests, you can turn that into a little bit of a puzzle for yourself. Aqueous anions. Okay, so there's another table. I'll just cut this for you, and I'll put it in a new slide so you can turn that into a revision source. So again, cut along the horizontal and verticals, park them into a plastic wallet, keep it for your A level. It will be useful. Just park that there. Okay, so you can print that out. That'll be nice and useful for your A level. Okay, just notice that there is a difference between sulfate and sulfite. So when you're reading through questions, that'll be useful. There is an error here. So nitrate should not have a -2, it should be a minus charge. Okay, so please note that. Nitrate has a single negative charge. So identification of gases, this is something that you would have covered, I hope, at Key Stage 3, and it just keeps on coming back again and again. So again, what I'm going to do is I'm just going to turn this into a revision source for you, and again, you can print out the slide, and you can turn that into a revision source for yourself. Hydrogen and oxygen, just remember, well, you know, glowing splint has a no, so just put that in there. And that's pretty much it. That's all you need to do. Okay. So what I've also done is I just want to highlight the Seneca quizzes. About 10 minutes ago, I was checking the Seneca. It wasn't actually working. It was a little bit of a late hour, so I may not necessarily have a chance to go through it, so I'm going to give it a shot. I've set you the IGCSE chemistry topics 6 to 10, okay? And the cations and anions activities that would be great for you to use to enter are there, okay? Now, hopefully tomorrow morning, because it is it's a late hour right now. Hopefully tomorrow morning you'll be able to access that, and you'll be able to see your scores. Now, if you have been living under a rock for the past 4 or 5 weeks, what I have done is I have slided into one of the presentations the link to the Seneca Learning. Okay, so you can reach it there. Okay, and that's really it. But you know, I think you realise that you have all of my support. I will see you on the Google Classroom. You know, it's just a review lesson. Have some fun. You know, just like in between doing all of your uploads of portfolios, you know, just turn these into little revision games. Just keep yourself occupied. You know, turn it into a quiz. That will be your task 2, okay? And then you've got your task 3. I'm going to turn your task 3. That will be your Seneca, and that should be enough to keep you occupied for the for this lesson. Okay. Best of luck. And again, what I will do is I shall see you. I hope to see you at the on the Google Meet. If you've got any problems, any questions, any midnight crisis, just drop me an email, and I'll help you out. No problem at all. All right. Okay. Stay safe. Stay at home, guys. Look after yourselves. Stay positive, and keep in touch. Take care. Bye.